This graphic compares two different approaches to building AI agents. On the left, a visual agent workflow as implemented in n8n. On the right, a graph-based agent architecture as seen in LangGraph. Starting with the n8n workflow, everything begins with an input. This could be a user request, a webhook trigger, or any external event. That input immediately flows into the AI agent node. Here, the agent uses a language model, or other AI core, to interpret the input. Once the AI core has parsed the request, two parallel branches open up. One branch leads to a tool call node. This is where the agent can invoke an external service, anything from a database lookup to an API call or custom function. The other branch goes to memory, where the agent can either store new context or retrieve relevant past information. After both the tool call and memory lookup, or storage, are complete, execution converges on a decision node. At this point, the agent's logic decides whether it has enough information to form a final answer or needs another iteration. Finally, once the decision is made, the workflow ends at a response node, which sends the AI-generated output back to the user or next system. In this n8n style, you can visually drag and drop nodes: input, AI processing, memory, tool calls, decision logic, and response. Then link them with arrows to build a clear, linear flow. On the right, the LangGraph approach uses a graph-based modular structure. Rather than one monolithic AI agent node, LangGraph begins by defining a global state node. This state object holds shared context, facts, variables, or flags that all downstream nodes can read and update. From state, you branch out to multiple agent nodes, here labeled Agent 1 and Agent 2. Each agent node represents a specialized AI subcomponent. For example, Agent 1 might handle natural language understanding, while Agent 2 manages business logic or user personalization. Those agents both connect down to a central tool node. The tool node performs external functions, much like n8n's tool call, but in LangGraph it sits at the center of the graph so any agent can invoke it. Below the tool node is a conditional node. Here, you evaluate whether the workflow should proceed, retry, or terminate. If the agent's combined outputs or the tool node's result indicate retry, the graph loops back to a continue node that feeds back into the initial state and agent nodes, enabling iterative processing. If the condition is done, execution follows the done branch into an end node, concluding the flow. The dashed arrow on the left side of the LangGraph section shows how, after a continue action, the workflow can circle back into the same state agent tool sequence. This loop continues until the condition flips to done. In other words, LangGraph explicitly models each agent and the shared state as graph nodes, then uses conditional edges to control iterative loops or final completion. This graph structure makes it easy to see which agents run when the tool is called and how state is updated on each pass. Key differences: n8n is visual and linear. You drop an AI agent node and connect it in a diamond shape so that memory and tool calls happen in parallel before a final decision. LangGraph is graph-based and modular. Multiple agents read and write to a shared state, then converge at a tool node, and finally route through a conditional loop that either retries or ends. Ultimately, both approaches let you integrate AI reasoning with external tools and memory, but n8n emphasizes a straightforward drag-and-drop flow, while LangGraph emphasizes an explicit node and edge graph that can loop until a condition is satisfied. Your own models, build intelligent agents, and leverage vision-centric generators, all while tapping into community resources. You'll be well on your way to mastering generative AI and applying it in real-world projects.